Find the dimensions of the rectangular coral split into two pens of the same size, producing the greatest possible enclosed area given 900 feet of fencing. Assume that the length is greater than or equal to the width. Okay, so the first thing we need to do is we have to draw a diagram of the coral split into two pens, labeling the sides, the length, which is L, and then the width. Now, we assume all of the fencing is used to enclose the coral and separate the two pens. So what that means is that we have another width here and another width here, which means we have a total of 3 widths. And we have a length at the bottom, which means we also have a length at the top. So we have a length here and a length there, and then we have our 3 widths. So, since there are 900 feet of fencing available, we can express the total amount of fencing in terms of W and L using the equation. Okay, so we have 3 widths plus we have 2 lengths, and it's going to equal 900 feet. Okay, so now that we do that, what we're going to want to do is we have to use also the area of a rectangle. Okay, so by using the area of a rectangle, we want to be able to determine, okay, what is the value of L here? So we're going to have to solve for L in this equation. Okay, so let's solve for L. So if we have 2L, that's going to equal 900 minus 3W. And if we divide both sides by 2, then we get 900 minus 3W divided by 2. Okay, and now the next thing we need to do is we need to write this in terms of the area. So we know that the area is equal to the length times the width. So what we've done is we figured out what L represents, and L represents 900 minus 3W over 2, and we're going to plug it into the area formula here. So what's going to happen now in step 2 is we have area, which is going to equal the length, which is 900 over 2 minus 3W over 2, since it shares the denominator. And then we're going to multiply that by a W. So therefore, A is going to equal 900 over 2 W. So 900 over 2 W minus 3 over 2 W squared. Now, let's go ahead and write this as a function in terms of W. So A of W, we're going to write this in ascending order. So we have negative 3 over 2 W squared. Okay, and then 900 divided by 2 becomes 450 W. Now, if you take a look, we now have a quadratic equation. So in order for us to figure out the greatest or the maximum possible enclosed area that we can use here to find the dimensions, we need to use the vertex. So first thing we need to look at is the value of A. And so the value of A is negative 3 over 2. And since that's less than 0, we know it's opening down. And that tells us that that is a maximum point. Okay, we also know that B represents 450. And we know that C is equal to 0. So now we can find the vertex, which is H, which is negative B over 2A. So that's going to equal negative 450 divided by 2 times negative 3 over 2. Well, in the denominator, the 2's are going to then become 1. We have a negative divided by a negative, so that becomes 450 divided by 3. And so 450 divided by 3 gives you 150. Now we need to find the value of k. Well, the value of k is finding f of 150, and then we're going to plug it into our function. So we have negative 3 over 2 times 150 squared plus 450 times 150. So we have negative 3 over 2, and if we take 150 and we square that, we get 22,500. And then if we take 450 and multiply that by 150, then we get 67,500. Okay, so if we take 22,500 and then divide that by 2, then as you can see here, if this is going to be negative 3 times 11,250 plus 67,500. And so if we multiply that by negative 3, and then that gives us negative 33,750 plus 67,500. And what that gives us is 33,750. So what does that tell us? Well, what that tells us is that the vertex is located at 150 and 33,750. Okay, so what that means is this represents the maximum amount. Okay, and so this 150 represents the width. Excuse me. And so since the width is 350, then we know that the maximum is going to represent the area. So this represents the area, and the 150 represents the width. So let me go ahead and rewrite that. Okay, so now what we need to use the formula for the area. We know that the area, A, is equal to the length times the width. Okay, so we know what the width is, which is 150. We know the area is 33,750. Okay, and they wanted us to find the dimensions of the rectangular coral split. Well, we know that the width is already at 150 feet. So we can solve for L by taking the area and dividing it by the width. Well, the area we have is 33,750. And we're going to divide that by the width, which is 150. Okay, and if we take 33,750 and divide that by 150, then we get 225 for the length. So now we can determine what are the dimensions. And so the dimensions are the following. We know that the width represents 150 feet. We know that the length is 225 feet. And even though it's not asking us, we do know that the area now is 33,750 square feet. Because again, that is the maximum amount of area that we can plug that in. So therefore, we found the width and the length to be the following.